Okay, in the system, we can see in this demo picture, in this architecture picture, we can see the development of the XCI concept at 5G-Crosshaul project. The XCI concept is the control infrastructure that is ruling the transport network. Due to the heterogeneity of the transport network, several domains and several technologies are combined. Here we can see at the picture how we have an edge transport network composed by wireless link featuring Wi-Fi links and millimeter wave links. And then we have another domain that is a multi-layer optical network. The XCI concept wants to treat this heterogeneity and this multi-domain infrastructure. So in order to do that, he's developing a hierarchical deployment when there is a parent orchestrator that rules the end-to-end orchestration of transport resources. Then at the top we have as I said, the parent app node controller, and then there is several child controllers that are aware of the technologies and are controlling the different transport technologies, namely the wireless part or the multi-layer optical part. In addition to this demo also features another key point of the 5G-Crosshaul project, that is the integration of front-haul and back-haul traffic through the same transport network. So on top of this transport infrastructure that we can see in the picture and that we are demoing here, we can see how we have deployed different entities of an LTE mobile network layer. These entities are an node B, the remote radio head and the baseband unit, and then the core network that is composed of the EPC. Okay, between the RRA and the BBU units there is flowing the front-haul traffic, and between the node B and the EPC it's flowing the back-haul traffic. Thanks to the kindness of the hierarchical infrastructure and the XCI concept of 5G Crosshaul, we can manage the different kind of traffics through the same network, combining different technologies, as I've said, and different domains. So this is what it's also a really important thing. So you can establish services at the time scale of seconds rather than maybe hours or days that it's normal in current transport network. So on top of the architecture, we have the application plane, that is the resource management application that, based on the information that it's capturing from the parent app node, is able to allocate the different flows according to the requirements of the different kind of traffics, front haul and back haul. So once the RMA has sent the call services, the parent app node parses it and separates it into the different domains, the wireless domain or the optical domain. So it's informing the child controllers what are the resources that it's going to be in the underlying transport elements, okay, at the physical layer. So it's a orchestration from a high level of abstraction to the physical layer that is a low level of abstraction. This is the graphical user interface of the child SDN controller at the wireless part. So here we have 4 wireless transport nodes that are featuring different kind of technologies also, Wi-Fi links and also millimeter wave links. So at the GUI we can see how after the process of RMA setting, determining the flows, and the parent app node determining the resources to be allocated, the flows are flowing through the different entities of the mobile network layer. And here at the GUI we can see how there is a ping between the 2 user equipment and how it's flowing through the different links of the wireless transport network. In particular, we are using millimeter wave to transport front-haul traffic, that is from the remote radio head to the BBU, and then from the BBU to the EPC. And on the other side, on the down part of the ring formed by the 4 transport nodes, we are forwarding the traffic of the pure backhaul traffic, that is the traffic that is generated from the UE attached to the node B, which is communicating to the core network.
Hello, my name is Xavi from NEC. So here I'm going to present you the RMA, which is on top of the XCI, which my colleague just presented. So we have the RMA, which leverages the controller that has below, which is the parent ABNO, and basically it requests for the topology and computes the path of the different end nodes in that topology. It uses the different information from the different splits needed in the end equipments, and computes the routes jointly according with the topology from the XCI. So in this screen we can see the underlying topology and the routes that the RMA has computed from the split requirements of the endpoints. So we can see how the node B has two different routes to the serving gateway and MME, and how the remote radio head goes to the BBU, and the BBU goes to the serving gateway and MME.